Hey everybody, welcome back to Adventures in Machine Learning. Today on the panel is myself, Ben Wilson, and
Daniel.
And our guest today is Abhilash, who's an ML engineer who has a pretty fascinating background and a lot of fun things to share in our topic today. Before we get into his intro, today's topic is going to be primarily around a topic that we've talked about a couple times on the show recently, which is what's next after you figure out how to get something into production, whether it be something incredibly simple or something that is incredibly complex with machine learning and deep learning. What happens after you get it into production? And what happens when it's no longer stable? How do you check for that? What are the best ways to do that, implement validations? And then also, how do you determine if that thing is still doing what you originally set it out to do?
Hey folks, this is Charles Max Wood from Top End Devs. And lately I've been working on actually building out Top End Devs. If you're interested, you can go to topenddevs.com/podcast and you can actually hear a little bit more about my story about why I'm doing what I'm doing with Top End Devs, why I changed it from devchat.tv to Top End Devs. But what I really want to get into is that I have decided that I'm going to build the platform that I always wished I had with devchat.tv, and I renamed it to Top End Devs because I want to give you the resources that are going to help you to build the career that you want, right? So whether you want to be an influencer in tech, whether you want to go and just max out your salary and then go live a lifestyle with your family, your friends, or just traveling the world or whatever, I want to give you the resources that are going to help you do that. We're going to have career and leadership resources in there, and we're going to be giving you content on a regular basis to help you level up and max out your career. So go check it out at topenddevs.com. If you sign up before my birthday, that's December 14th. If you sign up before my birthday, you can get 50% off the lifetime of your subscription. Once again, that's topenddevs.com.
So with that as our topic, Abhilash, please introduce yourself.
Hey, hi everyone. Hi Ben. Thanks for getting into the podcast. So I'm Abhilash. I'm from India. Currently, I'm working with Senchus, apart from the business and operations, leading the efforts in the business and operations. And so I was an engineer prior, and I drifted toward business because I see the opportunity and having a keen interest on business. So I did my master's in international business. So moving around the world and from Oxford to King's College to Japan. So I learned that there are certain nuances that I wanted to explore in artificial intelligence and machine learning. So I worked at one other company called Alpha, and it was primarily natural language voice assistant for Tableau. Pretty intriguing. And exploring that, I thought that let's start a business and let's do a lot of AI research in augmented reality. Why not mix those worlds? And I started Gideon. During that process, I explored this company called Senchus, and they were doing pretty amazing stuff. So we discovered why not take that next step in the machine learning pipeline? Why not take a next plunge? Why is everybody building models in production? Let's go next step forward. So we built a machine learning model AI observability platform, which basically monitors and gives you a result of the real world visibility of machine learning model. So yeah, it's pretty amazing. And yeah, we are going to talk about what you should be doing after your models are being deployed and how do you basically analyze the performance and monitor drips.
Yeah, so people coming from backgrounds that aren't in solving business use cases. So somebody who's not coming from a BI background, BI and analytics professionals and statisticians, when they get started early in their career, they know that data shifts and that everything that they're trying to build projects around is mutable. It is constantly shifting, regardless of what you're looking at. Data shifts, and it's really the underlying whatever problem you're trying to solve, whether it be you're analyzing customers or you're analyzing, like you said, natural language processing. How does language shift over time? How do semantics shift over time? Are you talking about NLP on official publications, or are you talking about analyzing stuff like Twitter and how people's speech patterns change mimetically over time? So if we were looking at something from the perspective of not a statistician or an analyst coming into working on ML, coming from a development background or a data engineering background, typically you're writing a project that you're not expecting things to change. You write controls around it and say, hey, I'm expecting that I'm doing a summation here. So I'm going to do a test that says, I'm going to test does 1 + 1 = 2. It passes. Okay, cool. But in the world of ML, that doesn't cut it. We don't write unit tests we do write unit tests that validate stuff like that, but we're doing validations of, hey, my data that's coming in and it's super complex. Can I ensure that each of these features that are coming into this algorithm are consistent? Do they have the same statistical distribution or the same ordinal distribution over time? So what did you learn? What was the big thing, the big game changer when you went from engineering into learning about ML and AI? Why the shift to focusing on post-deployment health monitoring?
So starting from engineering, shifting towards machine learning and, primarily MLOps, what a big change. And I thought that if you're solving the enterprise problem, you need to get into their data and get into their ML infrastructure. And one thing I've learned, which was a game changer, was machine learning models are not static, they are dynamic. And models can go away for numerous reasons. Maybe there is a drift, maybe there are KPIs not being met, maybe the predictions are biased. So solving all these questions, sometimes answers are sought when that happen and it's very late. So for that reason, multiple things go awry. So for example, if there is a concept drift, so it might be concerning to a data scientist. If there is a new model version performing better or not, that might concern a machine learning engineer. When in fact, if I'm talking from a business perspective, is the business KPI being met or the predictions are biased or not? That might hamper the outcome of a business leader. So to address all of these machine pipeline issues, so I thought there was a missed opportunity that we can bridge. And these are the limited knowledge of model behavior in real world that can have far reaching consequences. Just to address that, without continuous monitoring, data quality issues and model drifts creep in silently, causing models to fail, resulting degrading the business out. So, because of that and this particular missed opportunity, we kind of thought that okay, this is what we can offer and how we can monitor these kind of potential compliance issues, or maybe we can do the model checks. So, with no way to analyze model performance across different versions and environments, all these practitioners rely on ad hoc processes, resulting in slower resolution issues. So, that's why we took this plunge on building this AI observability platform. So, it will make effortless to monitor the pipeline as well as analyze issue and explain the models. Because one problem that we currently face as well is the black box. In the absence of model explainability, teams cannot understand why a model decision was made or whether it's biased or resulting in models that are not robust and fair. So explaining model, again, that's a pretty big step in the model observability. So yeah, this basically made the change.
You brought up a really interesting point that I haven't heard a lot of people talk about that much. I mean, I repeat it a lot, not so much on this podcast, but when I talk to individual people about, what does production ML really look like? And we focus so much as an industry on model metrics. Like, hey, how do your cross-validation metrics, what's your error loss looking like on this model? And I use those as for tuning whenever I'm building an implementation, but I don't care about them really because it's just an estimation of how well you're correlating. And when I tell it to people, that they're like, "Well, what do you mean? Like RMSE is the goal of a linear model. You need to just focus on that." I'm like, "No, I don't care. The business doesn't care." And there's also a disconnect between the output prediction of your model and how it actually influences reality. And you brought that up in what you were saying. There's this little gold nugget in your speech there that you mentioned KPI and how well does that particular solution solve a business problem, and the disconnect that can happen that I've seen, and it's actually burned me before previous jobs that I've had where I implement something, we run predictions on a scheduled basis, this goes into some table, and then some people read that table and make business decisions based on that. We're not going to directly couple our pipeline output of a prediction to our bank account. I mean, I'm sure some people do. I wouldn't recommend it. But there's always a human in the loop whenever you're talking about a serious influential model, unless you're talking about direct business to customer type stuff on websites. But if we're saying, for instance, if we had a model that's predicting what is the potential profitability of our company purchasing property, and We go out and say, well, the land value we're predicting of this plot of land is so many millions of dollars. And if we were to develop on it and then sell that, how much profit would we get? So we'd build an ML model to sort of extrapolate that based on the features of that region and what we're going to build there. And we do some simulations. Well, we're not going to have that model's output directly go and start filing paperwork to purchase that plot of land. Somebody's got to sit there and look at that and make a decision. So if we're not monitoring not only the output of the prediction, but how people actually use our models and what is that impact to the business itself, then we can very easily misguide ourselves into thinking the model's not performing because the business isn't performing.
Mm. And I think, your data is only good on what's going on in the current year because, data is very relative. Right now at my current job, I'm working in a healthcare industry and we're trying to use natural language processing to predict what medications you want. So obviously before 2020, the text descriptions you were going to ask for something were going to be nothing related to COVID. But then suddenly in 2020, 2021, if you're using an existing model and then people are suddenly entering things for COVID-related diseases, like shortness of breath or whatever, your model is going to fall short or be widely inaccurate. So it makes sense that you want to have something, to measure techniques for concept drift. I'm sure your project has special metrics to measure concept drift, let's say sentiment analysis or topic modeling, modeling what type of words, and to have some sort of metric to give you an automatic alarm if something is automatically off, for example.
Yeah. So I'll break it down in very simple terms. And you were saying?
Oh, you were asking me?
Yeah, I was saying I want to break it down into very simple.
Yeah. Go ahead.
Yeah. So first of all is identify. So we can put up monitors on top of every monitor just to see what sort of monitor that we're putting. Let's say we are putting data quality monitors, performance monitors, and drift monitors. So in drift monitor, we have data drift, concept drift. For performance monitor, we have accuracy, specificity, precision, sensitivity, all of that, missing value. For data quality monitors, we have data management, all of that. So these monitors basically identify issues before it's too late. Of course, you are going to put an alert on that based on the severity level, that how it might impact the performance of your model health. Now, the second part, we probably perform the root cause analysis to understand model anomalies. So you can pinpoint to the root cause and deep dive into it and understand, okay, why this particular thing happened and what should you be doing to fix that model. Now, this way you can get to the third side, basically better AI performance for the real world and for the future. So it's pretty easy to set up monitors because we have configured predefined monitors as well, just to cater to the enterprises, as well as you can build your own monitor. Then you can track these monitors and track the violations and analyze issues without writing any codes. So that's how you can observe the entire model as well as the entire project. Let's say your project have 10,000 models, you can track those things. So we made it pretty easy to handle for any of the use cases that we're talking about.
So monitoring without having to set alerts. Sounds like probabilistic programming to me, which is super cool. So if you're talking about probability that a particular event comes in, if we're looking for, say, a black swan event, COVID is a pretty big black swan event over the last decade. 2008 financial crisis, another one. I mean, some people saw that coming, but most people didn't. When we have everything just get table flipped in front of us, the entire nature of what we're trying to model just goes completely nuts. That's one thing. And those are really, really hard to detect beforehand. But when they do happen, you really know that it's happening because everything falls apart. But what you're talking about, where you could have 10,000 features that you're looking at and going through your monitoring tool. And to do that historically, you would have to do a bunch of EDA on those features and on the predictions as well. If you're talking about hundreds of models, that takes a lot of time where you're looking at each feature and saying, all right, over a time horizon window, what is the distribution of this? What is the variance within these bands? What should I set my alerts to? But you're talking about doing that autonomously to set those, which is, could you talk a little bit about what that probability alert would be, say, on a continuous feature?
Yeah. So you can integrate Senchus platform directly with your models. So you have to log in and enter all your log details. A pretty simple Python SDK, and you get to this platform. Then you can set up monitors on top of that. Okay, so depending on whatever the severity level, depending on what the conditions that you're putting, as well as the threshold, you can add these monitors. And you can check those on a real-time basis. Okay, and eventually we are catering towards building a segregated dashboard for individual projects that you can see. It will help to the CXOs and the BBS level, which are the business leaders. So that's where we are catering to. And about these predictions and the models, yes, it is real-time data that we are using, and yeah, I mean it's a lot in process. I would agree when it comes to natural language processing data and computer vision. But yeah, at the moment, supervised data that we are processing.
Awesome. So interfacing with this, and what sort of infrastructure would you need in order to interface with your product?
The best part is it is platform and product agnostic. So we know that companies use open source tools like Tfetch, Feature Store, Feast, or Dust. So we integrate with all of these tools as well. And we also provide cloud and on-premise solutions for the same. So it depends on companies' infrastructure, how mature their machine learning infrastructure is, as well as what sort of tool that they're using for model deployment. And is there any models are in production? So based on that, we kind of integrate this particular platform because it's a pretty easy process. Like hardly take 5 to 6 minutes to get started.
And that's really palatable when you're talking about managing infrastructure of this nature. If you don't have a service that you're using, such as this, setting all this up for yourself for one model and one project, yeah, it's probably a couple of sprints worth of work. At the end, like, hey, okay, we have this solution. We know what our features are. We're setting this up for operational usage in production. Mm-hmm. And then you're going to do a couple of sprints of saying, all right, let's make sure that we're monitoring all of our features. Let's make sure we write this ETL that's going to be analyzing all of this and giving us a report every day or every 6 hours or every hour. And then analyzing the prediction, saying, based on our train data, here's what the prediction or that came out of that was since the last time that we trained it. And then all of the predictions that we're generating over through time, we're going to compare it to that and say, do we have drift here? What is our Earth mover distance between these two? And as you do that for one project, yeah, it's a couple of sprints worth of work. But when you're talking about enterprise level, which is what you're mentioning, supporting that, some of the enterprise accounts that I've interacted with, it's these big companies that are fairly established in the ML AI space, they'll have 2,000 models in production and retroactively going back and building that monitoring for that is pretty substantial.
And the dirty secret with a lot of companies is that the people who monitor the production, like you might have huge companies like, Moody's or Johnson & Johnson, but the data science team and the production team, it all goes down to like 3 or 4 people and 1 or 2 people who are monitoring everything. So, it's up to that 1 or 2 people who make or break everything. They're the ones who have to like deploy everything. And one of my last jobs, like the person who was responsible for productionalizing everything, he basically had no life because he had to like monitor all these things that are going up, monitor the reports. So something like that, could give him a lot more hours in rest time the way the companies are structured at the moment.
Hi, this is Charles Max Wood from Top End Devs. And lately I've been coaching some people on starting some podcasts and in some cases just taking their career to the next level. Whether you're beginner going to intermediate going to advanced, whether you're trying to get noticed in the community or go freelance, I've been helping these folks figure out how to get in front of people, how to build relationships and how to build their careers and max out and just go to the next level. So if you're interested in talking to me and having me help you go to the next level, go to topenddevs.com/coaching. I will give you a 1-hour free session where we can figure out what you're trying to do, where you're trying to go, and figure out what the next steps are. And then from there, we can figure out how to get you to the place you want to go. So once again, that's topenddevs.com/coaching.
That brings up it's almost like a meta discussion about why companies like the one that you're working for right now, Abhilash, why they're a thing right now. And this disjointed structure that has happened over the years at most companies, where the data science and ML teams are segregated from engineering typically, because they're just building a model and they're running experiments, and it's a different sort of work. It's a different working model, but it's also a different paradigm that they're operating in. It's not, you can't take pure agile principles and put it to machine learning work. It just doesn't work. You have to adapt it in some way. And because of this, and the lack of experience and knowledge in a data science team of software development techniques, it just means that they're siloed to a certain degree. So you need this bridge, like, oh, we need to hire ML engineers and we need to hire an ML DevOps person. Just as Daniel said, one person, probably not the best idea, but usually a team at a big company of maybe a dozen people that are doing that ML ops pure focused work. But it's further segregating out. When you do that, when you silo these teams, it's a handoff process. You're kicking it over the wall to the next person. Like, hey, I built the model, not my problem anymore. That's ML Ops team's problem. And then ML Ops team is like, okay, we have 147 models that we're monitoring right now. We have to write all of this, boilerplate monitoring code around all of these processes. It delays the project even further. And when you need to make a change to something, they're too busy to respond to immediate needs because they're monitoring everything. So that having services that glue all of these critical functions together and make it so that you shouldn't have to manually build all of this stuff. It should be automated. It really does save a lot of time and effort.
Yeah, I second that because when we were talking to a couple of these companies from finances, they were putting man hour to monitor these machine learning pipelines, and they were going bonkers about it. So I agree that in a huge enterprise, there are substantial amount of data and a huge amount of models that are in production. But I'm talking about monitoring the machine learning pipeline and automating it from data behavior to model performance. So this is going to help these data scientists to identify issue and root cause analysis. And I firmly believe that we should encourage these practices these days, like automating this monitoring process in our industry, given the impending amount of volume of AI model and data that are coming our way. It's just starting. And monitoring an AI solution in production is not as straightforward as it seems. As you said, it turns out that only performance monitoring is not enough because, sure, metrics such as accuracy, precision, or recall values are the basis for understanding the model cell. But in high pressure production environment, just like we speak of bigger enterprises, knowing if precision or accuracy went down won't solve the problem as quickly as needed to avoid customer impact. So this is why AI monitoring needs in several layers. While model performance is a critical aspect, data quality, data drift, and concept drift are also the key to not just detecting problems but solving them proactively. So
Yeah, definitely. And it's highly use case specific too. I've had the benefit over the last 4 years of interacting with so many different industries. So it's not like, oh, I specialize in retail or something. You name it, I've interacted with them. And it's very fascinating to see how different industries respond to the concept of data drift and model performance drift when speaking about how fast they have to respond to something. A power company, for instance, they're not too terribly worried about their models needing to be retrained more often than every 6 months or so. I've seen models that the last time they were trained was like 5 years ago, and you look at the actual prediction versus actuals in their monitoring reports, and they're we're talking fractions of a kilowatt hour on predicting how much demand there's going to be. They're just really robust models, but the underlying data is not really changing that much. The features don't change. And then you talk with large volume financial traders, and you realize that they're retraining their models multiple times a day. They have active retraining systems where they're kicking off asynchronous retraining on recent data because the feature drift is so extreme and so fast that they need to respond to that as quickly as possible. And they have to build a lot of infrastructure around that. And it turns out most of that infrastructure code is many times bigger in number of lines of code, complexity, and amount of time to develop than the actual implementation of the solution was to begin with.
Yeah, so a lot of the financial companies, they really have to, think on the fly because one of the popular systems being used now is like AML or anti-money laundering. And even though there's like a lot of things being updated, this is one of the few things where criminals can actually get more inventive than the financial companies themselves. So you train up an AML model, and within a few months or a year, criminals find a very, very inventive solution. So you have to have like professional investigators come in to analyze like all these new crimes. Sometimes you get maybe some new psychological insight into what is going on and can be published for its own paper. And I think it also relies on a certain type of openness because some industries, when they see maybe a concept drift, they might fall into like the black swan paradox and think like, oh, there's something wrong. This really can't be true. I mean, that's happened, like, let's say with Bernie Madoff, because the prospect for fraud was so outrageous that no one could really contemplate it. So, but I think given people are understanding like the fast moving nature of data, they're accommodating it more and more, especially like, given the writings about Black Swan events and so on.
Definitely. I mean, they're really tricky. That one that you brought up in particular is an interesting one. It's events like that which influence the entire industry's need to try to detect those things as quickly as possible. And the more often that they happen, the less often that similar ones happen because people start saying, oh, geez, we don't want that to happen to us. We just saw how that just completely tanked an entire industry. We got to make sure that we're monitoring all of this stuff, but also that we're triggering off of those monitors. So Abhilash, in your company's offering, do you offer something like a passive retraining system or an active retraining system where you say, okay, we've detected this concept drift, the model is no longer performing, or the model has been trained in a distribution of the data that the current features coming in have the model's never seen that? Is there some functionality where you can call to a service and say, hey, retrain the model right now?
Yeah, so with a continuous scan of incoming data that is going through the monitor, like the data type and data ranges, so it is possible to track the disturbances and in the input stream even before the model gets chance to predict the garbage value. And especially with the concept and data drift monitors, it is possible to instantly detect and find potential solutions to these variable and these behavioral drifts, such as statistical changes in data or changes in the relationship between independent and dependent variable. So yeah, I would say this is what is really happening to the data behind the black box of AI solutions. So yeah, we surely can set up those sort of alerts, but again, this is something very new. Having said that, a black swan event can disrupt the entire pipeline, and we won't be seeing that sort of an outlier prior to it. But yeah, there are better predictions and better algorithms are in place. So yeah, we will achieve it one day.
Yeah, something that I've always recommended to people who bring this up about black swan events, like, hey, what happens if everything goes crazy and my model starts predicting values that are not possible within the realm of physics? You have some linear model and now it's predicting that sales are going to go up in the next day. And you look at the number and you're like, I'm pretty sure that's more than the GDP of our country for the year. I don't think that's going to be possible. So I've always recommended to people to have fallback logic where you have some cap on any prediction and that the end output of that model is never going to be exceeding that or going below that, so that you have some sort of boundary on there, because you don't want to send to internal business users or certainly to a customer some prediction that just doesn't make any sense. Now, when you mentioned earlier about bias and how terrible that can be, what sort of response do you typically give to a user when they're analyzing their model for some sort of bias, and how do you communicate that?
Yeah, so with respect to bias, yes, it can change the prediction and as well as eventually affect the model lifecycle. So we address it by keeping threshold, so that if the parameters cross that particular threshold, of course, we are going to set up monitors and set up alerts so that you can get to the root cause. And this is how you can observe that if there is a change in data quality, And this is one of the greater issues that we are trying to solve, that having the data quality monitored, because this is going to give us the models, and that is going to be eventually impacting the performance. So if we can check it from the beginning, that what data goes in and what data goes out, of course, we can check in with the performance bias as well as the model fairness.
Yeah, I mean, it sounds like it's a comprehensive solution. So what is the roadmap going to look like for the tool? Like, where do you want it? Where is your company's vision over the next 2 years, 5 years, 10 years?
Yeah, that's a great question. So for the time being, we are focusing on supervised data, and we want to explore more into NLP and computer vision data, because that's again in our roadmap, and we want to perfect our product so that it will be a seamless integration with any of the integration that we are looking in the ML infra stack. So that's part one. Second, we want to partnership with all this adjacent companies that are currently existing in ML, because catering to the masses, because we are talking about a very niche product and very niche segment of MLOps. So we want to scale it through and through. So that would require a lot of service integration as well as partnership. So like we were saying, as well as perfect the product over and over in aspect of explainability, because that is the one black box we are trying to solve. And yes, by explaining models and model decisions, teams can build better performing and responsible models to increase trust for their stakeholder. So, for example, understanding the why behind model decisions, improving the performance for specific cohorts, and detecting these unwanted bias and fixing models, as well as the ensuring that the models stay compliant. So this would be our primary focus, and having more and more infrastructure as well as platform models, so that it will be a seamless integration for anybody to take a start with. Like that's where I'm seeing this product.
You were mentioning about explainability. Does your model have like ability for neural networks and explainability for neural networks? Because one of the big bugaboos in businesses is that they love to use neural networks, but unfortunately, it's very hard to get explainable features. Sometimes you have to train like a secondary model that gets like explainability by proxy. And that's probably what's limited a lot of companies from using like the full potential of deep learning, because sometimes some of the theorists in deep learning can say that, oh, this model is training so fantastically, but we have no idea like why it's training like that. And business will say, well, if we can't explain it to customers or data scientists, then it's worthless for us,
Yeah, completely agree with you. And yes, we are, I wouldn't say that we are there yet, like focusing on neural network and integrating deep learning techniques. But yeah, we are doing these kind of researches as well, and having more and more data and more insights is telling us how we are going to build this explainability, because that's the future and that's where we want to be with. So yeah, we are exploring the domains, and yeah, it's in the research.
Hey, folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium.
So are these things that you would pursue as a build versus or use existing prior art? You're saying, hey, we want to do explainability, so we're going to write our own algorithms and to have our own custom approach? Or is it, no, we're going to integrate with open source tooling that people use to do this? And for what you're saying, Daniel, that's like simulation modeling. You're like, hey, I'm going to create synthetic features. I'm going to run it through this pre-trained model. I'm going to see what happens. I'm going to hold fixed attributes associated with the tensor that's going in, and then see how I can manipulate it and what actually happens. Is the intention to do that? Like, are you going to staff up to support that, or are you just going to use stuff that's out there and integrate it to the solution?
So our focus is to integrate the explainability section to the monitoring part as well, so that you would get to the root cause and understand why that particular thing happened and how do you want to find out that. So that's part of the explainability. Of course, once we explore that domain and blend it through, of course, we are going to take it further on keeping it for the open source and making it available for everybody. So yeah, that would be the focus.
So your tool, where can people read about it more?
You can go to Sensus.ai and check for the AI observability platform. Even we have all the ebooks that basically caters to make you understand step-by-step process of how we are doing problems and how we are solving problems and what are the use cases that we're currently catering to, as well as how this business is basically formed and what the product integration look like, everything and anything. Even we solve the wikis. Like if you, let's say somebody who's coming from not a pristine data science and machine learning background, they wanted to understand the problem. So we made the wiki so that they won't feel like, okay, what is data quality? I don't get it. So they can check it out. And also, if a person is coming from MLOps and hasn't really explored the machine learning monitoring segment, or maybe somebody is coming from software development. Okay, software development is not machine learning. So he or she can learn about the adjacent industries as well, because we write blogs and very extensively, very amazing. You can highly encourage to read about it. So we write about all of these segments as well, from data ingestion, feature engineering, feature stores, and model deployment, everything. So we cover those segments as well. So it guides you to model monitoring and model observability. So you can check everything out on the website.
All right. Sounds good. Do you have any other questions, Daniel? Anything else you wanted to cover?
Yeah, I guess maybe one quick question is like, what do you think you're bringing to the field with your MLOps software compared to like competitors? Like, where do you think you have an edge?
Yes, good question. So I've seen our competitors, and they also bring this from ML monitoring and observability as well. So I want to bring two aspects of it. First of all, we are an early stage startup, and once we get into with the client, we are going to hold their hands till they get their performance better, and we are going to help them in step by step of every process so that they get their performance better of their model pipeline, as well as we are going to build product with them. That's part one from a human aspect. The second would be we are focusing on this umbrella platform, which is called observability, which comes in model fairness, model health, as well as monitoring and explainability. That basically differentiate us, and that is why we want to stand apart from all of these competitors. That we will deep dive into the root cause of your problem, and we're going to solve it in real time. So that's what we are bringing to the game.
Awesome. Yeah. I mean, hopefully you're enjoying yourself at the early stage startup. I think it's an interesting phase in the development of a company as you build these really rich relationships with your early clients, and I don't know, they almost become like friends, and you work together to solve some really interesting problems. And it's a lot of work, but it's very rewarding work.
Yes. No, it's very true. I mean, startups are working with like all these cutting edge ideas. Sometimes some don't pan out, but then others grow so big. You know, so many companies like Amazon, Microsoft, they started out as startups and, you know, they grew into huge multinational corporations that you see today. So I really think, you know, it sounds great that you're going to be working on something that, you know, might potentially upend the field.
Yeah, so adding to that, one thing I would like to say that we really need these solutions tailored to our emerging needs. The reminder that you should always wrap code that originated in third-party companies, especially when you're dealing with young startups. And if you're using open source solutions, you should keep in mind that due to complexity in this emerging field, client or community supports are highly important. And when the need for monitoring becomes apparent, you should make a list of all these features that will be important to you and find a solution that ticks most of the boxes. Now, that's how we want to differentiate ourselves. So, always engage in conversation with the solution providers, and I strongly recommend that talking to a tech-oriented person, we call it. So, especially when you're part of a startup, because your personal use case may be slightly different than the intended solution that they provide, and it may be important for them to support it. So yeah, I truly hope that this podcast plays out an important role. And when you need to adapt and implement a data science-centric monitoring service, you will have all the additional ideas and information. So,
All right. So thanks for talking about what your platform is and what you guys are working on. It's a fascinating talk. It's exciting to hear so many different companies that are being formed around this problem space and how far a lot of them are getting into this sort of unified vision of making sure that ML doesn't suck when it's in production, that we're making stuff that's bringing value to businesses, to customers, to the world in general, hopefully, depending on what you're working on. So it's great to hear and see. So if people want to get in contact with you personally, what's the best way that they can ask you questions, just reach out and chat with you?
They can reach out to me over LinkedIn, so it's pretty easy. Also, yeah, they can reach out to me over my email. It's abhilash.patnaik@sensus.ai. So, yeah, happy to chat, happy to talk to people in the industry.
All right. We'll have all of those links in the description to the show on the website. So, yeah, once again, thanks for coming on and chatting with us. It's just really fun. And hope to talk again someday. So, yeah.
Yeah, it was a great honor to have you. Yeah.
All right. So that wraps up this week's episode, everyone. Got to learn about some important aspects of model monitoring, data monitoring, and how to make sure that your productionized ML solutions stay in production and don't get told by the business to be turned off. So on behalf of the panel and our guests, thank you so much for tuning in, and we'll see you next time.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.